Hello everyone, and a very warm welcome from IT Next in association with VMware. Thank you for joining us today. And today's topic of discussion is virtual storage with virtual SAN, the new tier of storage. So VMware software-defined storage strategy basically focuses on a set of VMware initiatives regarding local storage, shared storage, and data services. So the software-defined storage is designed to provide storage services and service-level agreement automation through a software layer on the hosts that integrates with and abstracts the underlying hardware. vSAN, or virtual SAN, is a new software-defined storage solution that is fully integrated with vSphere. And the virtual SAN aggregates locally attached disks in a vSphere cluster to create a storage solution that rapidly can be provisioned from VMware vCenter during virtual machine provisioning operations. Today's speaker is Mr. Vivekanand Biradar, who has been working as a senior technical consultant for over 6 years in the areas of infrastructure, virtualization, disaster recovery, and software-defined data centers. Now, before I hand over the platform to Mr. Vivekanand, I would like to request everyone to hold your questions till the end of the presentation. If you have any questions, you can post it in the chat box, and we'll take it up once the presentation is done. Now, Vivekanand, I would request you to take over.
Hi, thanks, Arun. Thanks a lot. Good evening, gentlemen. So, as Varun described, the topic for today's discussion would be software-defined storage. Another way, we'll be discussing more on the first-in-line product that VMware actually brought in to this particular portfolio, called virtual SAN. The current version of that is 5.5. It came with the release of our vSphere 5.5. It's integrated with that. So, as you see, VMware coined this terminology called software-defined data center almost like 1.5 years back now. We were the first ones to come up with this terminology, but now it's become an industry standard, and now everybody starts using this. So what does this terminology consist in it? When I say software-defined data center, it is to includes compute, network, storage, and automation. I'm saying when it comes to compute, VMware has been leader in this market, so we did help customers virtualize their entire compute servers and create them as virtual components within each one of these servers and run your applications in them. Got thousands of customers doing this in India here who have gone ahead and already on path of software-defined compute. We didn't stop there. We went ahead and even started our journey on software-defined network. If you've been hearing news, VMware acquired a company called Lycera, which was again pioneered in doing software-defined networking. What VMware did earlier in virtualization space, Lycera was exactly doing the same thing on networking, which is to virtualize the entire networking components. Now that is fully integrated into VMware's software-defined data center terminology now. And not just that, we went ahead and even started our journey on software-defined storage. Now today's discussion would be mainly focused on that particular area, which is to help customers transform the way their applications are using storage. How are we providing the right kind of performance to the application? So we'll be discussing on them. If you look at the storage market in itself, I think 20 years back, we had local attached disks in all the servers, which resulted in islands of storage, and the biggest pain point that customers had was utilization was very poor. Now, hence a new technology came in, through which we actually moved to shared storage. So instead of having individual disks in every server, we went ahead with shared SAN. It could be SAN or NAS arrays, which really helped us improve the TCO, But again, these boxes, if you really see, have become a large part of our IT cost. I'm saying 50% of our IT budget or the data center cost actually is consumed by storage. And this is where we're seeing a new innovation. A lot of new findings have been coming in. We're seeing server flashes becoming more viable in terms of cost now. The cost of rotating media disks continues to plummet. We're finding abundant amount of CPU cycles in these servers, which now we can implement at a higher level to get more functionality from software instead of just depending on the firmware. Now, not just that, we're also seeing a hyper-converged solution that simplifies the consumption of storage. And finally, and which is the most important piece of it, is we're seeing object storage and cloud economics also significantly impacting the entire cost of storage. Now, this is what I spoke earlier, right? Which is hyper-converged storage opportunity that we are seeing. This is exactly VMware did when we brought in the technology called the virtual SAN, which is to provide an abstract layer above the storage with the help of vSphere hypervisor itself, which now helps you pool any amount of storage, be it local, be it residing in SAN NAS, or it could be residing in some sort of cloud storage. With the help of hypervisor, we are abstracting all of this and providing it to individual applications as per the SLA that the application really needs it. Now, the application knows that what kind of performance that it really needs. It can come from any kind of storage below. The good part about it, now it sits directly onto the I/O, so whatever I/O that you actually want for that application is being generated and being provided to the individual applications. Moreover, now it is completely hardware agnostic. You can have local storage, you can have a sandbox, you can have cloud storage, and see that as just an amount of data storage is being provided to an application. The application is simply hardware agnostic now. Now, if you really see where again, how does this hypervisor transform storage? Traditional scenario, we create multiple LUNs in multiple arrays and provide that as a single point of connect to individual virtual machines. Now, software-defined storage is really different. And this is where we transform the way the storage is being used by these applications inside the virtual machines. First of them is simple. It could be a hypervisor-converged pool, which is just to abstract the local storage from the disks. It could be coming from a SAN or a NAS pool, or in a simple way, it could come from a cloud object storage, where each one of the disks which is being allocated to the individual VM is being defined based on the objects. When I say defined based on the objects, each one of the entity inside the storage is different now. Gone are those days where we used to go ahead and create a LUN, create a RAID group. Yes, we do that even today in a traditional SAN architecture, but this is how cloud storage is completely different. We don't define any such mechanisms of creating a logical unit or creating a RAID kind of architecture for providing the right kind of performance and capacity for the applications to run. Now, when I say software-defined storage, each one of this storage is actually managed by a piece of software. When I say software, all the SLAs, all the policies which need to be provided, which need to be adhered to individual applications, is defined with the help of software. You define, the application actually defines what kind of performance that you want. So if you want the kind of performance that you really want from the storage, it could come from a converged pool, or it could come from a SAN pool, or it could come from a cloud object pool. Depending on what kind of performance is required, storage policy decides, helps you decide that. And not just that, if at all you want any kind of data services, for example, you want to replicate this virtual machine or replicate this application to another DR site, or you just want to keep snapshots of these individual applications in the same data center. Again, these are fully defined with the help of storage policies, which is again a significant part of the entire software-defined storage that we have. Just to reiterate again, with the help of software-defined storage, we create a virtual data plane which sits directly on top of individual storage entities that we have. This data, it also helps us create virtual data services, which is to provide backup to individual VMs or ensure 100% availability for individual application and guarantee the performance which is required for every individual application. Now, all of this is driven through policies. Now, these policies are actually defined by storage, defined by the software which comes built into the software-defined storage portfolio itself. Now, who are the partners who are helping us? So, if you see, most of the industry standard industry leaders into this particular segment, which is into storage segment or the backup software, which a lot of our vendors support, are into this segment. So it's not just the VMware who is going on our own. We are actually partnering with the broad ecosystem that we have in this segment. With the help of each one of them, we are creating, getting into storage virtualization space with the help of software-defined storage. Where does virtual SAN sit in? Now, the entire discussion of our today's topic was on virtual SAN. So, virtual SAN as in itself, which is in its first phase of journey, the first release we brought in on virtual SAN is to help customers use their local disks as Hypervisor-Converged storage pool. Now, with this, we actually help customers simplify the way storage is actually being managed in the local disk which is available in the server itself. Now, how do I help radically simplify that? It's very simple. Every one of us, most of us who have gone ahead and created VMware vSphere infrastructure would know how simple it is to go ahead and install the hypervisor. Now, vSAN by default is actually integrated in the hypervisor itself, which when I say it's integrated, all you now need to do is go ahead and just simply install a vSphere on the hypervisor. vSAN is just pre-built into it. You just have to go ahead and enable vSAN on the hypervisor. That's it. No other configuration required in order to go ahead and use virtual SAN. Virtual SAN is intelligent enough to go ahead and abstract all the storage is available as local within the server, and not just within one server. It just expands in itself as and when you keep adding more and more servers. All the disks which are locally attached to individual servers gets pooled and helps create a big data store. When I say big data store, you can call it as a big SAN, a shared SAN kind of data store. And now I can go ahead and allocate them to individual VM based on the policies that we want to define at an application layer. For example, I want to have high availability for one very critical individual VM with maximum performance that needs to come out of the SAN. Now I can go ahead and define that at every individual virtual machine layer. Now, we've seen in huge amount of traction on this particular product when we actually launched the beta of this into August 2013. We easily have about 12,000 plus beta customers who actually participated in this program, and almost 95% of them actually recommended. When they actually went ahead and tested this product, they're so excited about the use of this, because it first starts your journey with software-defined storage on a local SAN storage, but doesn't end up there. it's in no way of going ahead and managing the entire storage arena with the help of software. And 90% of them actually believe that there is huge impact of storage that the vSphere did earlier to compute. Now, which is what vSAN will do. Now, why customers should go ahead and use virtual SAN? It's very simple. One is it's very easy for you to go ahead and install it. Just 2 clicks. For anybody who has gone ahead and created a DRS cluster or a HA enablement on a cluster, I'm sure it just takes about just a couple of clicks. Go ahead and click check mark the box next to distributed resource scheduler or to HA, and backend vSphere takes care of the entire configuration part of it. There is no other manual intervention required. Similar to that, virtual SAN will be an additional option that customers would get just below DRS. Now just have to go ahead and check the box called virtual SAN. All the configuration in the backend is fully automated and taken care by virtual SAN. It aggregates all the storage and helps you create a SAN kind of infrastructure for your virtual machines. Now, it's fully policy driven. That is how we call it simple. You don't have to really worry about what performance would I actually get from the underlying SAN. It doesn't really matter, because all we are doing is we are providing the right performance for individual applications. Whatever performance that you want, put it in the policy. vSAN will give you all those IOPS, all this capacity, ensure high availability to that individual application with the help of the storage policy that we define. Moreover, we don't have to really worry about the performance that we get, because it is fully scalable. Today, when vSAN got announced, it could go ahead and give you a maximum of 2 million IOPS from just 32 nodes, and which itself shows the amount of scalability that vSAN can provide you with the just help of vSphere kernel itself. And finally, why customers were really excited about this event, it is because it really helps you lower the entire total cost of ownership. The reason being, now we just have to add disks to the storage, disks to the SAN, disks to the existing servers in itself. So there is no large investment that you are doing in anything upfront, and it's also very easy to go ahead and operate and automate is because as and when you keep adding more and more disks or more and more servers, the storage just gets scaled up. There is no additional configuration required. You don't have to really worry about reconfiguring the entire SAN storage. Let's say traditionally, if you buy a big SAN box and you want to expand that, if you add another SAN from a different vendor, you would really not see a big SAN cluster being created of 2 different brands of storage. A whole lot of configuration changes needs to be done in order to fully use the entire SAN box, which is not the case in vSAN. Just keep adding additional disks or additional SAN, additional servers to the individual servers to the vSAN cluster, and it just keep adding to it. Now, how do we build a vSAN node? When I say vSAN node, it's nothing but a physical server which has a lot of inbuilt internal local disks. There are customers who have gone ahead with this. There are 2 ways to do it. One is vSAN ready node. When I say vSAN ready node, there are already predefined configuration available from various vendors, from Cisco, Dell, IBM, Fujitsu. You see multiple options from the day we went ahead with this product. We've got GA. We already have 30 plus different variants of vSAN ready node, which customers can just go ahead and buy it. Or the second option is if you can rebuild this from scratch. See, you already have a lot of physical servers. Just have to ensure that any one of these physical servers, whichever you are using, are vSphere compatible server. If you are already running vSphere on it, be it very fine. You can go ahead and reuse that server itself. All you have to buy is just an additional SSD drive and few set of SATA or SAS disk, which will actually give you performance for SSD and capacity for the SAS and nearline SAS or SATA disks that you would want to use it as in capacity or for storing these individual VMs, and a RAID controller to connect to these hard drives. You can check the compatibility guide for ensuring the right components have been chosen and build into the local storage, build as local to the individual server itself. There are two ways where you can go ahead and create a vSAN ready node. Now, in terms of flexibility for performance capacity, you can start with as small as just 3 servers, and with that you can get up to 6 terabytes and IOPS up to 20,000 in itself from as small as 3 servers, and it can grow up till 32 nodes and give you huge amount of storage. So the one which I mentioned on the slide here just shows you the kind of configuration that you can look at for defining the amount of capacity and the performance that you want from the individual servers. Again, in terms of the partner ecosystem that you see, in terms of servers and storage, we almost have every industry standard verticals coming in. The leaders in servers and storage are already in line with the virtual SAN. They have ensured all of their servers and storage are fully integrated and supported with this new product called virtual SAN. And not just that, we also have the data protection team, which is again industry leaders like Symantec, VM, Commvault, EMC. They're fully certified their solution with virtual SAN. Now, we've seen the real benefit of going ahead with software-defined storage. Now, let's look at how Simplifiedly I can actually go ahead and deploy this and ensure the virtual machines or the application is always highly resilient even in case of hardware failure. Assume there is a virtual machine which is running on the second server, which you're seeing on this slide. If any one of the components inside that particular server fails, simply doesn't matter, because each one of these availability is actually predefined at a VM layer. If it fails, it's fine. Quickly, another virtual machine gets restarted in another server because the data of that is fully replicated in another server. And now, the good part about vSAN is once a VM is been rebooted in another server with the help of HA, it immediately starts creating another clone of this VM on another server, which means there's zero data loss even in case, whether in case of a disk failure, network failure, or host failure, anything. All of this is actually defined at a VM layer. Whenever a server fails or a disk fails or a network fails, immediately the virtual machine actually goes ahead and restarts another server, which ensures there's zero downtime from the disk or network failure. Now, good part is it is fully integrated with VMware HA and maintenance mode. A lot of times, a lot of our customers who are using vSphere HA, I'm sure will be very happy that you don't have to do any other means of different configuration. VMware vSAN continues to use vSphere HA as a means for ensuring there's no failure in terms of the application. It quickly automatically brings up the VM in another server. Now, in terms of scalability, it's just linear scaling for both performance and capacity. So as and when you keep adding additional servers or additional disks, the capacity just keeps increasing. And not just that, if you add additional SSDs to ensure if you want high amount of IOPS or high performance coming in from your underlying cluster, just seamless. You can just keep growing or shrinking as and when you have more and more demand coming in. Just keep adding additional disks or additional nodes. There is no downtime that is required for you to reconfigure the cluster. As and when you keep adding additional disks or additional server, the capacity just keeps getting increased linearly. In terms of the maximums, you would see vSAN today can is scalable up till 32 hosts and 3,200 VMs which could run. I think that with the .1 release or the 1.0 release of vSAN itself, we are able to scale up to a capacity worth 4.4 petabytes and about 2 million IOPS. That was the biggest achievement that VMware in itself had in terms of providing heterogeneous scalable storage. We also did benchmarks of having a mixed kind of SAN cluster with VDI kind of environment. So we were able to generate the same kind of IOPS that you would ideally get in a virtual SAN array with a all SSD array. I'm saying the kind of performance that you would wanted for a VDI kind of environment, which is again the biggest bet that we have for usage on vSAN. We see traditionally a lot of places VDI kind of project doesn't really fly because of the enormous amount of cost involved onto a storage segment. Now, vSAN is a real good option for all of these customers where we started the VDI project, but we couldn't actually go live because of the enormous amount of storage costs. Now, with this, we've benchmarked and seen enormous amount of virtual machines actually running as in VDI environment on a vSAN cluster. There is huge amount of scalability. So as and when you want to add additional virtual desktops, you can just keep adding additional servers or additional disks and keep expanding your number of VMs. In terms of the configuration, I told you earlier, as simple as enabling your DRS cluster or a vSphere cluster. All you have to do is just turn on the virtual SAN, and virtual SAN or the cluster in the backend takes care of the backend configuration of collecting all the disks which are part of the local storage, as in local storage in the server itself, and creates a big shared SAN pool and provides that as a data store to individual virtual machines where you can define the right amount of policies with the help of vSAN. And not just that, once it's been created, you can see that as a vSAN cluster now. You can even integrate VMware vCenter operations and check the health and the efficiency that you have at a vSAN data store itself, whether it's been fully utilized, optimally utilized, and all these things. You can see in our current cluster, the screenshot that you're seeing, the 8 amount of hosts which are eligible for this vSAN cluster, and giving you a total capacity of about 36 terabytes in itself. Now, in terms of its integration, it's fully integrated with most of our VMware, almost all VMware features. From a vSphere perspective, it's fully integrated with vMotion, HA, DRS, storage vMotion. So any features which are currently using from vSphere perspective, they are fully integrated. And if you want to take a backup with using VDP Advanced or Snapshot, again, it's fully tested, certified to run with vSAN. And as I said earlier, virtual desktop, which is again our biggest bet for vSAN environment, is something that we would ideally want customers to go ahead and use it. In terms of automation, it's fully integrated with vCenter Operations Manager and vCloud Automation Center. Again, a big time product which most of the service providers actually use for providing cloud as service. It's fully integrated to be used even in big cloud scenarios. And the another use case is this disaster recovery to help customers do DR with Site Recovery Manager. A lot of times you've seen customers using local disks in the DR site without availability. Now, Site Recovery Manager with the integration of virtual SAN can help customers bring in availability even in a DR site. And finally, the integration with our storage policy-based management, which is to provide profile, which was earlier called as profile-driven storage. is fully integrated with vSAN. You can go ahead and put any kind of policies that you want to define at an individual VM is fully integrated. In terms of its use case, apart from the VDI which I spoke earlier, the other use cases that you would see is tier 2 and tier 3 kind of applications, where a lot of times customers wanted the high availability for test and dev applications, and but were not able to get, or ideally had to go to SAN kind of architecture for avoid getting the high availability. Now you can have it on a vSAN kind of architecture in itself. Even in DR kind of segment, or a backup for DR, which is again a bigger use case for vSAN, along with an isolated DMZ kind of environment. A lot of times I've seen customers putting a DMZ segment in a different VMware cluster and having a SAN kind of architecture, which you can avoid with the help of vSAN in itself. Let's look at in a different way, in a traditional way versus in a vSAN architecture, how and what challenges that we face. A lot of the times, if you see with the traditional architecture, which is to provide SAN architecture to individual applications, we see the biggest challenges that you see is forecasting. We really don't know how much of SAN it is actually required, or which I need to forecast for this year, for next year. A lot of times it is very difficult to change policies once you have allocated. So once you have created a RAID group kind of array, or you have defined the kind of IOPS that you actually get from the SAN storage, you really want to go ahead and change that. It is really time consuming and a lot of configuration driven stuff, which involves a lot of hardware configuration. And if you want to change any policies for individual applications, which is changed now, again, this is really difficult in itself, and in terms of data migration, when you want to change all of these things, it really is a lot of complexity involved in a traditional SAN architecture. But this is completely different in a virtual SAN environment. It's very simple. Over provisioning, it's okay. You can still go ahead and do that. There's nothing called really over provisioning in a vSAN kind of architecture. You just go ahead and define as per the policy, and if you want to go ahead and change that policy, just go ahead and change it. There is no reconfiguration or restart to any individual application, or no downtime actually required for any kind of policy change that you would want to do at an application layer. All of this is defined at a VM layer, and if you want to go ahead and change it, it's simple, it's radically simple. Just go ahead and change it. vSAN itself takes care of the right kind of performance that you actually want from the underlying storage. As I said, vSAN simplifies and automates your entire storage management in terms of the storage policy that you want to define, in terms of capacity, performance, availability. Okay, let's say capacity, how much amount of disk that you want to give to individual VM, what kind of performance that you want, whether you want 100 IOPS, you want 500 IOPS, or you want the entire data to be striped, you want it to be available, you want the failure to tolerate for that individual virtual machine to be higher, so you want multiple times it to be replicated across multiple servers to get high availability. All of this can be easily set with one policy in itself, or you can have multiple different policies to ensure you have higher level of SLAs for every individual virtual machine. You don't have to define it at a server layer or at a storage layer, because now you can go ahead and define it every individual VM layer itself. In terms of the TCO ROI, you see there is upfront reduction in the CAPEX environment itself, because now I don't require the entire fiber channel network itself. There is no HBS required, there are no fiber channel SAN switches required, no additional SAN storage required for you to go ahead and get the same kind of capability that you would eventually want from a SAN architecture. And moreover, I'm just using the same servers which traditionally been using for a vSphere kind of infrastructure. Now, in terms of operational benefits, again, it's pretty easy to go ahead and configure this because it's at a hypervisor layer. Now, you just have to go ahead and enable virtual SAN at a server layer. I don't have to create any LANs, any RAID groups. It's already predefined. There's no RAID kind of architecture that we use here. Whatever is the amount of storage that's coming from the local storage, local server, is been given as shared SAN to the entire vSAN cluster. It also helps you automate the entire VM provisioning, ensure there's a right amount of performance that is being guaranteed with the help of vSAN. Now, in terms of just to give you a glimpse on the cost in itself, it's as low as $50 per desktop that you would eventually be buying this for. And in terms of the capacity, the cost of this is almost like $0.5 per GB that you would be buying this, which really helps you lower your entire operational expenditure by about 50%. This is what I actually had from today's presentation. If at all you have any questions, you're free to ask. I've put some additional resources which you can use it in order to get more details and more product knowledge on virtual SAN. That's it from me.